Okay, today we're going to be talking about multiplying fractions. Okay, so if we start at the top, we're talking about the area models below, represent two multiplication problems. Use your understanding of example A to complete examples B and C. So when we multiply fractions, we just multiply them straight across, okay? And when we do that, we see that 2 times 3 is 6, and 5 times 4 is 20. But we have to understand that just because we can multiply fractions and get a certain fraction, it doesn't mean that fraction is as simplified as it needs to be. So how I got from here to here is that I started thinking about factors that could be multiplied into 6 and into 20. And there's only one number I can think of. That number is 2. So 2 can fit into 20, or into 6 rather, 3 times. 2 can fit into 10, or 20, 10 times. And so that's how we have a simplified fraction. We'll do the same thing here. We'll multiply 2 times 3 and 3 times 5. 2 times 3 will give us 6. 3 times 5 will give us 15. So now we need to think about factors that can multiply into either of those numbers. And the one factor I'm thinking of is 3. I know 3 can go into 6 twice, and 3 can go into 15 5 times. I'll do the same thing with the next one. 5 times 1 and 6 times 4. 5 times 1 is 5. 6 times 4 is 25. Now, there are no factors that can be multiplied into 5 and 25, so we're going to leave that fraction alone, and that's as simplified as it's going to get. Okay. Going to the next part, we see that it says, in order to multiply fractions and mixed numbers, each number must be written as a proper or improper fraction. That means our numerator is larger than our denominator. The number on top is bigger than the number on the bottom. Mixed numbers must be converted to improper fractions, and whole numbers must be written over 1. And I'll show you guys some examples of that later. Then we have some steps for multiplying fractions, okay? Change each mixed number to an improper fraction. Multiply numerators, multiply denominators, simplify. Okay, so we're going to do that with our first one here. I'm going to write them just a little bit bigger so it's easier for our eyes. 2/3 times 4/5. Multiply straight across. 2 times 4 is 8. 3 times 5 is 15. We can't simplify that fraction anymore, so this is our final answer. Moving to number 2, we have 6 times 7 times 2 times 7. Again, we're going to multiply straight across. 6 times 2 will give you 12, and 7 times 7 will give you 49. This particular fraction can't be simplified because 12 and 49 do not share a common factor. So this is basically how it's going to be left, okay? This is our final answer here. All right. On to the next one. Okay, here we're going to talk about what's called common factors. Now this is very important because this is actually a step we can use to help making simplifying fractions even easier. Okay, so let's get to it. Common factors between the fractions can be simplified. I'll write that right here, simplified. Okay? And we're going to talk about what that looks like. So When they talk about common factors, okay, I'm looking at my numerator and my denominator on the opposite fraction. So if I look at 3 and 3, those are common factors. 3 can fit into itself once. 3 can fit into itself once. And I'm good. 4 and 2 share a common factor of 2. 2 can be multiplied into itself once. 4 can be multiplied into itself, or into 4 twice. 2 can be multiplied into 4 twice. Which then gives us an answer of 1/2. So we can do that beforehand if it's actually applicable. If not, then there's nothing we can do. Here's an example of what we did earlier and how we would simplify after multiplication, okay? 2 times 3 is 6. 3 times 4 is 12. 6 can go into itself one time. 6 can be multiplied into 12 twice. Either way, we end up with the same answer. Okay? Now we'll do the same thing with this next one. Okay, let's go ahead and get into it. Okay. Here, 4 is a common factor. It can fit into itself once. It can fit into itself once. 3 and 9 share a common factor of 3. 3 can fit into itself once. 3 can fit into 9 3 times. When we multiply, we get 1/3. Okay, when we get to the mixed numbers, it's a little bit different because we have to convert these mixed numbers to improper fractions. So that's what we're going to do. And in order to convert, we have to multiply our denominator by our mixed number. Now, when we do this, our denominator stays the same, okay? So I'm going to write a 2 over here because it's going to stay the same. 2 times 2 is 4. 4 plus 1 is 5. So now I have 5 over 2. We'll do the same thing with our second mixed number. 5 times 3 is 15. That's going to be over 5. 15 plus 3 is 18. Now, I'm going to bring this over here so that we can see if we can simplify and multiply. Now, I do see some stuff here, okay? I'm noticing that my 5s share a common factor. 5 can fit into itself once. 5 can fit into itself once. 2 and 18 share a common factor of 2. 2 can fit into itself once, and 2 can fit into 18 9 times. You multiply straight across, you end up with either 9 over 1 or 9. They are the same thing. Okay, let's keep going with number 6, okay? Number 6 says that a recipe requires 2½ cups of sugar. If Mrs. Marina is going to make 1/2 of the recipe, then how much sugar does she need? Okay. So here we have to convert our 2 1/2 into an improper fraction. Remember, the denominator stays the same. I'm multiplying it by 1/2 because they're saying if Marina is going to make 1/2 of the recipe. So I'm going to get my denominator and my whole number and multiply that. That's going to give me 4. 4 plus 1 will give me 5. And now I have fractions I can multiply. Multiply directly across. I end up with 5 over 4. Well, 5 over 4 is still an improper fraction. So I'm going to decompose that. 4 over 4 gives me 1 whole. I know I can take 4 over 4. And what would be left if I took 4 from my numerator is 1. 5 minus 4 is 1. 4 over 4 is the same thing as 1. So my answer is 1 and 1/4. All right, for this number 7. A rectangle has a height of 1 1/4 inches and a base of 5/6 inches. What is the area of the rectangle? So there's actually a lot going on here. Okay, first of all, it's a rectangle with a height of 1 1/4 inches, a base of 5/6 inches, and the area. Okay, area equals length times width. We have to know that. It said a rectangle, so I'm going to go ahead and draw myself a little rectangle. It says the height was 1 1/4. The base was 5/6. I have to change my mixed number into an improper fraction. I'm going to multiply 4 times 1. That gives me 4. 4 plus 1 will give me 5. So now I have 5 over 4 times 5 over 6. Multiply straight across. I end up with 25 over 24. Well, that's still an improper fraction. So I'm going to decompose. 24 over 24. And what's left is 1 over 24. 24 over 24 is the same thing as 1 whole. Therefore, that is your answer. 1 and 1/24. Now, if I move up just a little bit, we're going to work on number 8. It says 4 students were each given a card with a fraction on it. They were then asked to pair up with another student and multiply the fractions. Okay. What I'm going to do here first is change Andre, Ellie, and Omar's mixed numbers into improper fractions so that all I have to do is multiply to justify what I need to know. So let's do it. I'm not doing it with Ira because it's already a regular fraction. It's not a mixed number, so I don't have to mess with it. So I'm going to multiply 1 times 4. 1 times 4 will give you 4. 4 plus 3 gives you 7. Remember, my denominator stays the same. So Omar's improper fraction is really 7 over 4. I'll do the same thing here. 7 times 2 is 14. 14 plus 2 is 16. Our denominator stays the same. So Ellie's improper fraction is really 16 over 7. Andre is 6 times 1, which is 6. 6 plus 5, which is 11. Andre's improper fraction is 11 over 6. Well, that works because now we can do some stuff, okay? Let's talk about this first statement. They want to know if it's true or false. We'll answer it, and then we'll explain very briefly why. When Omar and Andre multiplied their fraction cards, they got a product greater than 1. Okay. It says they got a product greater than 1, greater than 4. Okay. Let's see if it's true. I'm going to get Omar, and Andre. And we're going to multiply it directly across. We end up getting 77 over 24. Now let's think about this. They said their product is greater than 4. Okay. Let's see if we can make a small list, skip counting by 24. It's not that hard. So 24. This would be 24 times 1. 4 twice and 2 twice will give you 48. That's 24 times 2. Another 4 and another 2 is going to give you 60. No, 30. What am I talking about? My bad. 12. Carry the... Yeah, 62. No, 1 second. Alrighty.
Can I use your stapler?
Yeah, right there. No problem. Hey, what's up?
I do have a meeting today, just a heads up. Hopefully it'll run short,
No worries.
but just want to let you know.
I got you, man.
Awesome.
No worries.
Thanks, man.
No problem.
Appreciate it.
Okay.
I had my first phone call home today.
It's not good. If I add another 24, then I have 6 and 8. Obviously, that's not going to work because our answer here is 77. They said their answer is greater than 4. This is 1, 2, 3, 4. That's not greater. This is false. 77 over 24 is less than 4. Can you close the door on your way out? Thanks, man. I appreciate that. Yeah, no worries. So that's not going to work. Okay? For B, if Ira multiplies her fractions by any of the other cards, the product will be less than 1. Well, let's find out. Ira is 1/5. So let's see. Here's Ira 1/5 times, let's just work back. Andre. Okay, Andre, let's see what you got. I'm going to multiply these together, and I get 11 over 30. Well, if I need 30 pieces, but I only have 11, I definitely have less than 1. So far, so good. We're going to try Ira against Ellie. Okay, multiply straight across. You end up with 16 over 35. Again, if I need 35 pieces, but I only have 16, I have less than 1. So far, B is true. Let's do our last one just to verify. Here's Ira. Here's Omar. 7 over 20. Same thing. If I need 20 pieces, but I only have 7, I clearly have less than 1 whole. Therefore, B is true. 11 over 30. 16 over 35 and 7 over 20 are all less than 1. Looking at C, our last little thing here, it says when Ellie and Omar multiplied their fraction cards, their solution. Their solution was between 2 and 3. Let's find out. Ellie and Omar. Omar, you are 7/4. Ellie, you are 16/7. This is good because I actually see some common factors here. 7 and 7. 7 can go into itself once. 7 can go into itself once. What about 4 and 16? They also share a common factor of 4. 4 can go into itself once. 4 can go into 16 4 times. if we multiply straight across, we end up with 4 over 1, or just 4. Now, is 4 between 2 and 3? No, not even close. This is false. Okay? See you guys later.